Rupesh Kumar from Government Polytechnic Narayanket. I want to share some information regarding the digital electronics. Topic is TTL NAND gates. Already we have completed the number systems, conversions and Karnaugh maps, K maps, logic gates, etc. And also we learn about the logic families, types of logic families, characteristics or specifications of logic families, about the TTL gate, ECL gate, CMOS gate, comparison between these digital IC families as well as the IC numbers also, digital IC numbers also we have undergone in our previous sessions. Today we will learn about the TTL NAND gate open collector circuits operation and TTL NAND gate bottom pole circuit and its operation. And name the universal gates, why they are so called, what are the semiconductor devices used to construct the gates. These are the topics which we are going to learn in this session. Already we learned about the transistor logic is a widely used family. Transistor logic is widely used family. It is fast, inexpensive and easy to use. It is fast, inexpensive and easy to use. Bipolar transistor technology is used for MSI and SSI, medium scale integration and small scale integration. It is used to build all kinds of digital circuits and systems. It is easy to build all kinds of digital circuits and systems. TTL is a widely used logic family. TTL means transistor logic. The basic element in TTL circuits is bipolar transistor. Bipolar transistor is some of the TTL circuits. TTL technology utilizes multiple emitter transistor. In some of the TTL circuit, TTL technology utilizes multiple emitter transistors for the input devices, as well as bipolar transistors are used for medium scale integration and small scale integration. It is used to build all kinds of digital circuits and systems. It is about the TTL. Please have a look of it and kindly note in your notebooks. I have told you the basic element of TTL circuits is bipolar transistors, and this technology utilizes multiple emitter transistors. Multiple emitter transistors is used in TTL logic families. These 2 points also you can write in your notebook. Another one is also there. TTL means transistor logic. It is fast, inexpensive and easy to use. Okay, this is about TTL. Now we are going for the TTL NAND gate here. Please note the diagram. TTL NAND gate. Here already we told that TTL has multiple emitter transistor circuit. Yes, see here emitter has 2 inputs AB and 2 resistors R1, R2, 1 and 2 transistors Q1, Q2 and collector to collector voltage is VCC as well as ground is also exist here. We get the output that for NAND gate Y equal to AB bar. Okay, once again I am repeating, By viewing this diagram, we noticed that it uses the NAND circuits, so transistors with multiple emitter. In this we have two inputs, input A and input B, and two resistors R1 and R2, and two transistors Q1 and Q2, and one voltage collector to collector voltage VCC, and one ground. Output value Y equal to AB bar. This is the NAND, TTL NAND gate. Working of TTL NAND gate here I am showing to you. The simplest form of TTL NAND gate is shown here. The simplest form of TTL NAND gate is shown. The emitter terminals of the transistor Q1 are the two input terminals. The collector Q3 is the output terminal. If one of the inputs is 0, the corresponding emitter junction is forward biased. Collector junction is also biased. Hence, transistor Q1 goes into saturation. Hence, transistor Q1 goes into saturation. The simplest form of TTL NAND gate is shown here. The emitter terminals of transistor Q1 are the input terminals. The collector of Q3 is the output terminal. If one of the inputs is 0, the corresponding emitter junction is forward biased. If one of the inputs is 0, the corresponding emitter junction is forward biased. Collector junction is also biased. Hence, transistor Q1 goes to saturation. Here in the above figure, it is the simplest form of TTL NAND gate. In this, the emitter terminals of transistor Q1 are the input terminals here, and collector of Q3 is the output terminal here. If one of the inputs is 0, the corresponding emitter junction is forward biased. One of the inputs is 0, the corresponding emitter junction is forward biased. Then collector junction is also biased. Hence, transistor Q1 goes into saturation. Hence, transistor Q1 goes into saturation. Now, working of TTL NAND gate. The base of Q2 is at a low voltage. The base of Q2 is at a low voltage. If Q2 is off, output Y is high. If both the inputs are high, both emitter junctions are drive to reverse bias. If Q1 is cut off and its collector voltage increases, this voltage forward biases Q2. This is some confusing matter. I will simply tell to you that in NAND gates, if both the inputs are high, output will be high. It is the rule which we have in the NAND gate. Here also we are going to that one only. See here, if the base of the Q2 is at a low voltage and output Q2 is 0 or off, then output Y is high. If both the inputs are high, both the emitter junctions are driven to reverse bias. Both the inputs are high, then both the emitter junctions are driven to reverse bias. Q1 is cut off and its collector voltage increases. Q1 is cut off and its collector voltage increases. This voltage forward biases Q2. This voltage forward biases Q2. Okay. Now Q2 goes into saturation and output Y is low. Q2 goes into saturation and output Y is low. Thus, if any or all the inputs are at logic 0, output is logic 1. If all the inputs are at logic 1, output is at logic 0. Hence, the circuit functions as a NAND gate, follows the truth table. Here, Q2 goes into saturation and output Y is low. Q2 goes into saturation and output Y is low. Thus, if any or all the output inputs are at logic 0, the output is logic 1. If all inputs are at logic 1, the output is at logic 0. Hence, The circuit functions as NAND gate, follows the truth table. Now we are going for the another type of TTL NAND gate, but by going to that, the TTL circuits may employ three type of gate output arrangements. They are totem pole output, open collector output and tri-state output. Here we are going for the open collector output here. Open collector TTL NAND gate. Open collector TTL NAND gate here. Here also it is having three transistors Q1, Q2 and Q3 and three resistors R1, R2 and R3 and two inputs, input A, input B, directly connected to the emitter of the transistor Q1 and one ground as well as 1 minute. One ground and output Y equal to AB bar and a collector to collector voltage B. Once again repeating, in previous one and this one, here one resistor and one transistor is increased. Rest of all the values are same. Once again repeating, here three transistors exist, Q1, Q2 and Q3. Okay. Next three resistors exist, R1, R2 and R3 and two inputs, input A, input B, output 1, Y equal to AB bar and collector to collector voltage is VCC and one ground. Okay, input A, input B is directly connected to the emitter values of the transistor Q1. It is nothing but the open collector TTL NAND gate. Open collector TTL NAND gate. Now we are going for the working of open collector TTL NAND gate here. This circuit is similar to previous circuit. Transistor Q2 is used as an emitter follower. Here also transistor QT is used as an emitter follower and output of Q2 is fed to the input to transistor Q3. Collectors of Q3 and Q2 are in phase. The circuits needs an external resistor between output and the power supply. That is nothing but the open collector or external pull-up resistor. It is nothing but the external pull-up resistor. Once I am repeating, the circuit is similar to previous circuit. The circuit is similar to previous circuit. Transistor Q2 is used as an emitter follower. Transistor Q2 is used as an emitter follower. The output of QT is fed to the input of Q3 transistor. Collector of Q3 and Q2 are in phase. This circuit needs an external resistor between output and the power supply. It is nothing but the external pull-out resistor R. The circuit works properly if an external pull-up resistor is connected as shown. It is to be connected to the output side. It is a external pull-up resistor. The disadvantage of open collector gate is their slow switching speed and pull-up resistance is few kilo ohms. Pull-up resistor is few kilo ohms. The disadvantage of open collector gate is their slow switching speed and the pull-up resistance is few kilo ohms. It gives a relatively long time constant when multiplied by stray output capacitance. It gives a relatively long time constant when multiplied by stray output capacitance. Is worst when output goes from low to high. Is worst when output goes from low to high. Once again repeating, the disadvantage of open collector gate is their slow switching speed. The pull-up resistance is few kilo ohms, gives a relatively long time constant when multiplied by the stray output capacitance. When multiplied by the stray output capacitance, is worst when output goes from low to high. Is worst when output goes from low to high. Once again repeating the TTL, open collector, TTL NAND gate. See, by viewing the diagram, it is a 2-input TTL NAND gate with open collector output. It is a TTL NAND gate with open collector output as shown in the figure. Notice that output is the collector of the transistor Q3. Notice that output is the collector of the transistor Q3 with nothing connected to it. Hence it is known as a open collector output. Here output is the collector of the transistor Q3 with nothing connected to it. Hence it is known as open collector output. But the circuit is not completed, and in order to get the proper high and low logic levels at the output of the circuit, in order to get proper high and low logic levels at the output of the circuit, an external pull-up circuit or pull-up resistor must be connected between VCC and the collector of Q3. VCC and the collector of Q3. Once again repeating, a 2-input TTL NAND gate, 2-input TTL NAND gate with open collector output is shown in figure. Notice that output is the collector of the transistor Q3. Output is the collector of the transistor Q3 with nothing connected to it. Hence it is known as open collector output. But the circuit is not completed, and in order to get proper logic high and low levels at the output of the circuit, an external pull-up resistor must be connected with the VCC and the collector at Q3. VCC and the collector at Q3. Now operation of TTL gate, I am going to inform you. A low on either input A and B forward biases the base emitter junction of Q1 and reverse bias it base emitter junction, base collector junction. Here a low input A or input B biases the forward biases the base emitter junction of Q1 and reverse biases the base collector junction. There is a current through the resistor R1 and the base emitter of junction of Q1 out to the low input. Q1 out to the low input. That there is no current into the base of the Q2, hence Q2 is in off condition. At the same time, the emitter of Q2 is at ground potential. Keeping Q3 in off condition, when Q3 is off, output is pulled up to the VCC through the external pull-up resistor, resulting the output as high. Keeping the output of Q3 off, the output is pulled up to VCC through the external pull-up resistor, resulting the output is high. Second condition, when both the inputs are high. If both the inputs are high, base emitter junction of Q1 is reverse biased and its base collector junction is forward biased. Base emitter junction is reverse biased and base collector junction is forward biased. This permits the current through resistor R1 and base collector junction Q1 into the base collector junction Q2, thus driving Q2 to the saturation condition. As a result, Q3 is turned on. Q2 is in saturation condition, so Q3 will be turned on by Q2. When Q3 is on, the output is connected to near ground through the saturated resistor transistor, resulting the output as low. By this we can inform that it is working like that of a NAND gate only. So the truth table values are corresponding to this operation is matched together. So it works like a input and output conditions of the TTL NAND gate. Okay, it is nothing but the open collector TTL NAND gate here. Here one mistake is there. It is not Q2, it is Q3. It is not R2, it is pull up resistor. Kindly change it. Now we are going for another type of TTL NAND gate. It is a TTL NAND gate with totem pole output. It is TTL NAND gate with totem pole output. Here also it is like that of that one only, but major thing is here it exists 4 transistors here, Q1, Q2, Q3 and Q4, and one collector to collector voltage and 4 resistors here, R1, R2, R3, R4, and 2 input values, input A, input B directly connected to the emitter junction of the Q1 transistor, and in between Q3 and Q4 there exists a diode D1 for switching operation. It is the diagrammatic explanation of the TTL NAND gate with totem pole output. Once again I am repeating. Here by viewing this diagram we noticed that there exist 4 transistors, Q1, Q2, Q3 and Q4, and 4 resistors, R1, R2, R3 and R4, and 2 grounds and 1 collector to collector voltage and 1 output B out, and inputs are input A and input B directly connected to the emitter junction of the transistor Q1, and one diode is connected in between the transistor Q3 and Q4, in between the emitter and the collector of the emitter of Q3 and collector of Q4. We are having the diode D1. Okay, it is the TTL NAND gate with totem pole output. By seeing this diagram in this circuit, once I am repeating, Q1 and the 4 kg resistor, 4 kilo ohm resistor acts like a 2 input AND gate. Okay, in transistor and resistor acts like a 2 input AND gate. Remaining circuit acts like a inverter. Remaining circuit acts like a inverter. Transistor Q3 and Q4 forms a totem pole connection. Q3 and Q4 forms a totem pole connection, that is one NPN transistor in series with another. Totem pole connection means one NPN transistor is connected with the another transistor, forms the totem pole connection here. Once again I am repeating, in this transistor Q1 and 4 kilo ohm resistor acts like a 2 input AND gate. The remaining circuit acts like a inverter. Transistor Q3 and Q4 form a totem pole connection, that is one NPN transistor in series with the other NPN transistor. Next, with a totem pole output stage, either Q3 or Q4 is on. By using this totem pole output, either Q3 or Q4 is on only. Next, when Q3 is on, output is high, and when Q4 is on, output is low. If AB is low, A or B is low, Q1 conducts and base voltage of Q2 is almost 0, and Q2 is in cutoff condition, hence Q4 goes to the cutoff condition here. Once I am repeating, when Q3 is on, output is high. When Q4 is on, output is low. Q3 is on, output is high. Q4 is on, output is low. If A or B is low, Q1 conducts and the base voltage of Q2 is almost 0. So it goes to cutoff condition. Q2 goes to cutoff condition. Hence, Q4 also goes to into the cutoff condition. Now, Q3 base is high and Q3 acts as an emitter follower here. Q3 base is high and Q3 acts as an emitter follower. Then the output is Y is high. Then the output Y is high. Then the output Y is high. Now, if A and B are high, Q1 does not conduct and Q2 base goes to high. And Q4 goes into the saturation, hence output is low. The drop across the diode D1 keeps the base emitter diode of Q3 reverse bias. Hence Q3 is off, or else it conducts slightly when output is low. And now only Q4 conducts and output is low. Here see, if A and B are high, Q1 does not conduct and Q2 base goes high. Q1 does not conduct and Q2 base goes high. And Q4 goes into saturation, hence output is low. The drop across diode D1 keeps base emitter diode of Q3 reverse biased. Hence Q3 is off, or else it conducts slightly when output is low. Now only Q4 conducts and output is low. And now only Q4 conducts and output is low. Totem pole transistors are produce a low output impedance. The NPN transistors connected back to back, one to another means it produces a low output impedance. When Q3 conduction, the output impedance is approximately 70 ohms. Q4 is in saturated condition, the output impedance is only 12 ohms. Hence the output impedance of a totem pole circuit is low. Any stray output capacitance is rapidly charged and discharged through the low output impedance. Any stray output capacitance is rapidly charged or discharged through the low output impedance. Hence the output can change quickly from one state to another. When Q3 is conducting, the output impedance is approximately 70 ohms. When Q4 is in saturated condition, the output impedance is only 12 ohms. Hence the output impedance of a totem pole circuit is low. Any stray output capacitance is rapidly charged. Or discharged through the low output impedance. Hence the output can change quickly from one state to other. Strictly or quickly from one state to other. Okay. Once again I am repeating the totem pole NAND gate, TTL NAND gate, with the help of the diagram. Okay. See here, a TTL input, standard TTL NAND gate is shown here with totem pole output. Here Q1 is a multi-emitter transistor for the inputs A and B, and output transistors is Q3 and Q4 form a totem pole output arrangement. And the base of Q1 and the resistor R1 forms the AND gate, and rest of the circuit forms the inverter operation of that. If A or B is low, the base emitter junction of Q1 is in forward condition and its base collector junction is reverse bias. There is a current from VCC through R1. to the base emitter junction of Q1 and into the low input, which provides a path to the ground directly. Ground for current. Hence there is no current into the base of Q2 and makes it into cutoff condition. The collector of Q2 is high and turns Q3 into saturation. Since Q3 acts as a emitter, hence Q3 acts as a emitter follower by providing a low impedance path from VCC to the output, making the output into high. At the same time, emitter Q2 is at ground potential, keeping Q4 into off condition. Now, this is the same operation for a low on both inputs also. When A and B are in high condition, second condition it is. The two input base emitter junction of Q1 are reverse biased and its base collector junction is forward biased. Previous one, reversal one, this one. This permits correct to R1 and to the base collector junction of the Q1 into the base of the Q2 also, thus driving Q2 into saturation condition. As a result, Q4 is turned on. As a result, Q4 is turned on by Q2 and producing low output, which is near ground potential. At the same time, collector of Q2 is sufficiently at low voltage level. Collector of Q2 is at low voltage level to keep Q3 in off condition. By seeing this, we can summarize that all the input and output condition now that in the circuit, when diode is not present, Q3 will conduct slightly when the output is low. To avoid this, diode is connected, keeps the base emitter junction of Q3 is reverse biased. So we get the output that when both the inputs are high, output is 0, and when both the inputs are low, as well as if any one of the input is low, we get the output high. It is the condition for the NAND gate. So it follows the operation of the TTL NAND gate with totem pole output. Once again I am repeating. Here I have given a TTL input standard gate, NAND gate. In this 4 transistors Q1, Q2, Q3, Q4 and 4 resistors R1, R2, R3 and R4 and one diode D1 and 2 inputs A and B to connected to the emitter values of the transistor Q1 and a collector to collector voltage V, as well as 2 grounds also present here and one output Y. In between Q3 and Q4 a diode is present. It forms the totem pole output here. That means NPN transistor is connected with one to another. It is nothing but the totem pole output. Okay. In this, base Q1 and transistor R1 forms the transistor Q1 and the resistor R1 forms the AND gate, and rest of the circuit forms the inverter. Okay, now go for the operation here. If both the condition A or B is low or both the values are low, the base emitter junction of Q1 is forward biased and its base collector junction is reverse biased. Then there is a current from VCC through R1 to the base emitter junction Q1 and into the low input into the low input also, which provides a path to the ground for the current, which provides the path to the ground to the current. Hence there is no current into the base of Q2, making it into cutoff condition. The collector of Q2 is high and turns Q3 into saturation. Since Q3 is in emitter bias, emitter follower, Q2 may acts like a emitter follower by providing a low impedance path from VCC to the output, making the output into high. That means at the same time, emitter of Q2 is at ground potential, keeping Q4 into off. Note that this is the same operation for a low on both input also. Both input also same operation is there, or any one of the input is also low, this operation is correct. If when the inputs A and B are in high condition, the two input base emitter junction of Q1 are reverse biased and its base collector junction is forward biased. This permits current through R1 and the base collector junction of Q1 into the base of Q2, thus driving Q2 into saturation. As a result, Q4 is turned on by Q2 and producing a low output which is near to the ground potential. At the same time, the collector of Q2 is sufficiently at low voltage level to keep Q2 in off condition. By seeing these values, we can judge that when both the inputs are high, output will be low, and if both the inputs are low, as well as if any one of the input is low, the output will be high. By viewing this truth table format, we can judge that it follows the operation of the TTL NAND gate or NAND gate. That's TTL NAND gate with totem pole output uses a totem pole condition with arrangement of Q3 and Q4 with a diode D1. It helps the TTL NAND gate with in high condition when both the inputs are low or any one of the input is low. We get the output high, and when both the inputs are high, output will be low. Okay, please make a note of the diagram. Most important one it is. 1 minute, I will come to you. Please, diagram is more important. Here first Q1 resistor is R1, Q2 resistor is R2, Q3 resistor is R3 and Q4 resistor is R4. Remember that there are two grounds, one for Q2 and one for Q3, and a diode is present in between the Q3 and Q4 for performing the totem pole condition. It means NPN transistor is connected one with another. Okay, completed. Now I am going for the quiz. These three questions are most important. Any one question will come in your examination, or two questions also may come in your examination. Only 5 marks. Or he can ask 3 marks question diagram also. Diagrams also more important in this. Please have a look of it. Now, first question is TTL is a dash device. Anyone can guess it is? TTL is a fast device. Answer is fast. Second one, disadvantage of TTL NAND gate with open collectors is it. First one is slow switching speed. Second one is fast switching speed. Third one is slow and fast switching speed. Fourth one is all the above. Anyone guess? It is slow switching speed. Third one and fourth one. The use of pull-up resistor is proper power supply operation. The use of pull-up resistor is it is used to proper power supply operation. Use of diode in totem pole output totem pole circuit is one direction passage of current of output stage transistor. One direction passage of current of output stage transistor. It is the use of totem pole circuit. Diode in totem pole circuit. One direction passage of current of output stage transistor. Use of pull-up resistor is proper power supply operation. Now here I have given the frequently asked questions here. Please make a note of it. Draw a TTL NAND gate with totem pole output circuit and explain. Draw a TTL NAND gate with open collector and explain. Write the advantages and disadvantages of two circuits. Please complete this one. If you have any doubt, please complete these three questions in assignment book. If you have any doubt, you can ask me in the next session. Thank you. Thank you for hearing my class.